Now, let's try to relate between the velocity time graph and the acceleration time graph. So I brought in the acceleration time graph that we drawn in the previous video together with the velocity time graph that we have drawn in the velocity time graph video. So we are going to try and relate them together. Again, the principle that we use to relate between velocity time graph and acceleration time graph is similar to how we relate between the displacement time graph and the velocity time graph. We determine the gradient of the velocity time graph, and the gradient of the velocity time graph will be equal to the value of the acceleration that we obtain to be plotted in the acceleration time graph. Okay, the gradient over here will be representing the value of the acceleration that we can plot in this graph over here. Let's try to go section by section and to understand this principle more clearly. Okay, let's look at the first section. Again, we need to observe two things. The first thing is whether it's a positive or negative gradient. Okay, this is the shape of the graph that we have in the velocity time graph. So what do we observe? Whether it's positive or negative gradient. In this case, it's positive, it's sloping upwards, it's not flat, it's not sloping downwards. Positive, sloping upwards, therefore you get positive value of acceleration. Okay, the x component of acceleration. Then the next thing that you see, whether the gradient changes with time or not. If you observe here, the gradient does not change. It remains the same gradient throughout the whole journey. So it should be a constant absolute value of acceleration. Gradient constant, therefore acceleration constant. So it's a constant positive acceleration. Constant positive acceleration means by the acceleration should be above the time axis because it's a positive value of acceleration. Constant means by it should be a horizontal flat line because that means horizontal, does not change with time. Okay, so this is the first section. So how do we determine the value of acceleration that we should label over here? Well, again, I said the gradient in the VT graph is the acceleration that we get, right? So if you can find the gradient over here, that actually means we have already found the value over here. I plot here 1.5. How do I get it? Let's try and check it out. Okay, if we see here, this is an uniform acceleration. When it's a uniform acceleration, we can say that the instantaneous acceleration is equals to the average acceleration. What do we mean? If we find the average acceleration from time equals to 0 to time equals to 2, right? The average acceleration that we find will be equals to the acceleration that we find at any point of time between 0 and 2. Let's say I want to find the instantaneous acceleration at time equals to 1. At the first second, what is the instantaneous acceleration? If I find it right, the answer will be equals to the average acceleration that we find from time equals to 0 to time equals to 2. That's the property, one of the property if an object is traveling at uniform acceleration. When traveling at uniform acceleration, the VT graph looks like this, right? So the average acceleration across the whole period here, will be equal to instantaneous acceleration at any point within the time period. If I find the instantaneous acceleration over any specific moment within the time period, I will get the same answer as the average acceleration. Because the gradient doesn't change, so if you find the gradient anywhere, it should be equal to the gradient of the whole line itself. Okay, so let's try and determine it straight away. So we want to determine the acceleration, and we know that it's equivalent to the average acceleration across this time period. So how do we determine average acceleration? We take final x component of velocity minus initial x component of velocity, then divide by the time interval. Time interval is 2 seconds, then the final speed is 3, the initial speed is 0, so 3 minus 0, so you get 1.5. That's how we know what should we label over here. It's sort of like finding out the gradient because the equation for acceleration is actually a gradient formula actually. Okay, let's look at the second section. Second section here, you can see that the line is horizontal. So our velocity time graph has a pattern like this. Again, two things to observe. First thing, whether it's a positive, 0 or negative gradient. In this case, it's horizontal, flat line. So you should expect 0 gradient. That means your acceleration should be 0 value. Again, it's constant, so your acceleration is constant. 0 constant acceleration. So you plot nothing on your graph. And that is what we plot here, 0. Okay, so nothing to calculate here, it's just 0. Let's move on to the next section. Next section, you see a slope sloping downwards. So this is the shape of the velocity time graph. You should expect a negative gradient because it's sloping downwards. Therefore, the value of acceleration will be negative. Next thing, does the gradient change with time? No, it's a constant gradient. You don't get flatter, you don't get steeper. It remains in the same steepness. So gradient constant, that means your acceleration is constant. So it's a constant negative acceleration. So it should be below the time axis because negative, then it should be a horizontal flat line. Okay, next section. Oh, yeah, we need to determine the value over here. We need to determine the value that we need to plot over here. So how do we do that? Again, we know that the gradient is constant, so the instantaneous acceleration at any point in time is just equals to the average acceleration across the whole time period. So if you determine it, now this time the final is the later time, which is 0. The initial is the earlier time, which is 3. So 0 minus 3 divided by 2. The period here is 2 seconds, then you get negative 1.5. Okay, next section. Next section over here is again a slope that looks similar, just that it's below the time axis. So this is our graph. Again, we don't care about whether it's above or below. We still check the same two things. First thing, negative or positive gradient? Well, negative gradient, then negative value. Next thing, is it a constant gradient or a changing gradient? Well, it's a constant gradient. Negative constant gradient, so below the time axis, horizontal line. Again, what do we need to plot? We need to determine the value over here. To determine the value, again, it's final minus initial. Final is negative 3. Initial is 0. So negative 3 minus 0 divided by 2, then you get negative 1.5. This is the same as the 1.5 we determined for the previous section. So here we should label negative 1.5. Okay, negative 1.5. Okay. Next section, we have this horizontal flat line over here. Well, it's a horizontal line, you expect 0 gradient. So 0 gradient then doesn't change with time. The steepness doesn't change with time. Constant, so constant acceleration. A constant 0 acceleration. So you expect nothing on your graph. So draw it on the 0 on the time axis to represent the acceleration is 0. Last section shows a graph that is sloping upwards but below the time axis. So you draw something like this. This is the graph. Again, check two things. Is a positive or negative gradient? Positive, sloping upwards. So positive gradient means positive acceleration. Then the gradient remain constant as time progresses, right? It doesn't change to become flatter. It doesn't change to become steeper. So the gradient is constant, therefore it's a constant absolute value of acceleration. Okay, so if you have a constant and positive value, then we should expect the acceleration is above the time axis and it's a horizontal line. Okay, so this is what we plot over here. Again, we want to determine the value. So what do? We do our calculation. Again, using the same principle. This time our final will be 0. Our initial will be negative 3. So 0 minus negative 3 divided by 2, you get 1.5, which is the same as what we plot just now. Okay, so I have progressed section by section, showing you how to determine the shape of the acceleration time graph by looking at the gradient of the velocity time graph. And I've also demonstrated how do you calculate the value of acceleration to be inserted on the y-axis over here.